So, welcome back to the Walking Clearwater podcast. And today we are continuing the physics podcast series, and we are going to read a new chapter today, which is known as atoms. The name of the chapter is atoms. So, let's start reading from the basic concepts. One, Geiger-Marsden's alpha particle scattering experiment. On the suggestion of Rutherford in 1911, his two associates H. Geiger and E. Marsden performed an experiment by bombarding alpha particles helium nuclei Z is equal to 2, A is equal to 4 on a gold foil. Observations: 1. Most of the alpha particles pass through the gold foil undeflected. 2. A very small number of alpha particles, 1 in 8,000, suffered a large angle deflection. Some of them retracted their path or suffered 180-degree deflection. Conclusion: 1. Atom is hollow. 2. Entire positive charge and nearly whole mass of atom is concentrated in small center called nucleus of atom. 3. Coulomb's law holds good for atomic distances. 4. Negatively charged electrons are outside nucleus. Impact parameter: the perpendicular distance of initial velocity vector of alpha particle from the nucleus when the particle is far away from the nucleus is called impact parameter. It is denoted by B. For head-on approach of alpha particle, B is equal to 0. Angle of scattering phi. The angle by which alpha particle is deviated from its original direction is called the angle of scattering. B is equal to 1 by 4 pi epsilon naught Z E square by Ek into cot phi by 2, where Ek is the initial kinetic energy for head-on approach of alpha particle. Impact parameter is B is equal to 0. 2. Distance of closest approach. The smallest angle of approach of alpha particle near heavy nucleus is a measure of the size of nucleus. Distance of nearest approach almost equal to size of nucleus is equal to 1 by 4 pi epsilon naught 2 into 2 Z square by capital Ek, where Ek is the kinetic energy of incident alpha particle. Z is equal to atomic number and small e is equal to electronic charge. 3. Rutherford's atom model. Atom model. Atoms consist of a central heavy nucleus containing positive charge and negatively charged electrons circulating around the nucleus in circular orbits. Rutherford's model could not explain the neutrality of an atom, thermionic emission and photoelectric effect, but it could not explain the stability of an atom and observed line spectrum of an atom, atomic spectrum. For Bohr's model, Bohr's modified Rutherford atom model to explain the line spectrum of hydrogen. Postulates of Bohr theory. 1. Stationary circular orbits. An atom consists of central positively charged nucleus and negatively charged electron revolve around the nucleus in certain orbit called stationary orbit. The electrostatic Coulomb force between electrons and the nucleus provides the necessary centripetal force, that is, i.e. mv square by r is equal to 1 by 4 pi epsilon naught into Z e into E divided by r square, where Z is the atomic number, m is the mass of electron, r is the radius of orbit. 2. Quantum condition. The stationary orbit are those in which angular momentum of electron in an integral multiple of h by 2 pi, i.e. mvr is equal to nh by 2 pi, where n is equal to 1, 2, 3, etc. Integer n is called the principal quantum number. The equation is Bohr's quantum condition. Transition. The electron does not radiate energy when in a stationary orbit. The quantum of energy or photon is emitted or absorbed when an electron jumps from stationary orbit to other. The frequency of emitted or absorbed photon is given by h nu is equal to Ei minus Ef. This is called Bohr's frequency condition. Radius of orbit and energy of electron in orbit. Condition of motion of electron in circular orbit is mv square by r is equal to 1 by 4 pi epsilon naught into Ze into E by r square. Bohr's quantum condition is mvr is equal to nh by 2 pi, v is equal to nh by 2 pi mr. Substituting the value of V in the above equation, mv square by r is equal to 1 by 4 pi epsilon naught into Z into E by r square. So, we get m by r into nh by 2 pi mr whole square is equal to 1 by 4 pi epsilon naught into Z square by r square. This gives r is equal to epsilon naught into h square into n square by pi m Z square. Denoting radius of nth orbit by Rn, we have Rn is equal to epsilon naught h square n square by pi m Z square. Radius. And above was radius, and we also got the frequency velocity, which is nh by 2 pi mr, and the radius is epsilon naught h square n square by pi m Z square. So we have to remember this. For hydrogen atom, Z is equal to 1. Rn of hydrogen is equal to epsilon naught h square n square by pi m e square, as Z is equal to 1. The radius of first orbit of hydrogen atom is called Bohr's radius. It is denoted by a naught. A naught is equal to pi naught h square by pi m e square is equal to 0.529 into 10 raised to power minus 10 meter is equal to 0.529 angstrom. Energy of orbiting electron. From equation 1, mv square is equal to 1 by 4 pi epsilon naught Z square by r. K is equal to half mv square is equal to 1 by 4 pi epsilon naught Z square by 2r. U is equal to 1 by 4 pi epsilon naught Z into minus E by R is equal to, which is potential energy, is equal to minus 1 by 4 pi epsilon naught Z square by R. Total energy is equal to K plus U is equal to 1 by 4 pi epsilon naught Z into Z square by 2R minus 1 by 4 pi epsilon naught into Z square by R is equal to minus 1 by 4 pi epsilon naught Z square by 2R. For nth orbit, writing En for E, we have En is equal to minus 1 by 4 pi epsilon naught into Z square by 2 R nth. Substituting the value of Rn from equation 3 and 4, we get En is equal to minus 1 by 4 pi epsilon naught into Z e square by 2 into epsilon naught h square n square by pi m Z e square is equal to minus m Z square e raised to power 4 divided by 8 epsilon naught square h square n square. For convenience, introducing Rydberg constant R is equal to me raised to power 4 divided by 8 epsilon naught square ch cube. The value of Rydberg constant is 1.097 into 10 raised to power 7 meter inverse. En is equal to minus z square rhc by n square. For hydrogen atom, z is equal to 1. En is equal to minus rhc by n square. En is equal to minus 13.6 by n square electron volt. 5. Energy levels of hydrogen atom. The energy of electron in hydrogen atom Z is equal to 1 is given, or series of hydrogen spectrums by En is equal to minus RHC by n square is equal to minus 13.6 by n square electron volt. When n is equal to 1, E1 is equal to minus 13.1 minus 13.6 EV. Remember that En is minus RHC by n square, which equals to minus 13.6 by n square for hydrogen atom whose Z is equal to 1 atomic number. So when n is equal to 2, E2 is equal to minus 13.6 by 4 electron volt is equal to minus 3.4 electron volt. Likewise, n is equal to 3, we get E3 is equal to minus 1.51 electron volt, and likewise we can calculate it till infinity. So E infinity equals to 0 electron volt, because minus 13.6 divided by infinity square is 0. If these energies are expressed by vertical lines on proper scale, the diagram obtained is called the energy level diagram. The energy level diagram of hydrogen atom is shown in here a book. Clearly, the separation between lines goes on decreasing rapidly with increase of n, i.e. order of orbit. The series of lines of H spectrum are shown in figure B. If the total energy of electron is above 0, the electron is free and can have any energy. Thus, there is a continuum of energy states about E is equal to 0 eV. 6. Hydrogen spectrum. Hydrogen emission spectrum consists of 5 series. 1. Lyman series. Lies in ultraviolet region. Balmer series. This lies in visible region. Bastian series. This lies in near infrared region. Brackett series. This lies in mid infrared region. Fund series. This lies in far infrared region. Hydrogen spectrum consists only of Lyman series. Explanation of hydrogen spectrum. Ni and Nf are quantum numbers of initial and final state of Ei and Ef are energies of electron in H atom. Z is equal to 1. In initial and final states, we have Ei is equal to minus Rhc by Ni square and Ef is equal to minus Rhc by Nf square. Delta E is equal to Ef minus Ei is equal to Rhc into 1 by Nf square minus 1 by Ni square. If nu is the frequency of emitted radiation, we have from Bohr's fourth postulate nu is equal to Ei minus Ef by H is equal to minus Rc by Ni square minus Rc by Nf square is equal to Rc into 1 by Nf square minus 1 by Ni square. The wave number, i.e. reciprocal of wavelength of emitted radiation, is given by nu bar is equal to 1 by lambda is equal to nu by c is equal to r into 1 by Nf square minus 1 by Ni square. See, frequency is the formula is Rc into 1 by Nf square minus 1 by Ni square, and delta E, which is energy of absorbed photon, is Rhc into 1 by Nf square minus 1 by Ni square. So that we have seen that we heard EF is equal to minus RHC by Nf square and EI is equal to minus RHC by Ni square. So yeah, and the wave number is R into 1 by Nf square minus 1 by Ni square. We can remember it by like energy had RHC, nu has only RC, and wave number has only R. So in that way, we can calculate all of the wave number and wavelength and energy of different series. As we know that see, Lyman series has n is equal to 1, Balmer has n equal to 2, Bastian has n equal to 3, Brackett has 4, Fund has 5. So yeah, and that's how we calculate. And now that's for the chapter.